Now, a really helpful way of organizing information experimentally in the lab is by graphing some of the information that we have to kind of see initially if we think we have an overall first, second, third, zero order, whatever equation or reaction that's taking place. Because we usually use kinetics to learn about a reaction. We're trying to understand its mechanism, like what are all the steps that take place to make a chemical transformation take place. So that way we can optimize them. Uh, and so understanding the dependence of the rate on concentration is critical, and understanding the order of each of these reactants and their impact on the rate. And just knowing the overall order can sometimes help us determine which mechanism we're trying to evaluate is actually going on. And we'll spend some more time using these rate laws and integrated rate laws to determine what a mechanism is later in this chapter. The mechanism is just the steps that take place for a chemical reaction to occur overall. So, if you are going to be doing a kinetics experiment in the lab, you're going to be recording the concentration of your reactants or one of your reactants over time. So, you'll be like taking these concentration data points at regular intervals. And at that point, you can use that information to build a rate law, a differential rate law, like we showed before. But we can also use that information to show the overall order relying on our integrated rate laws and a graphical representation of the data. So let's say you got a pile of concentration information versus time. Well, if you can plot that information on a graph, you can quickly figure out the order. So if I take the natural log of the concentration versus time, I'll have this top graph up here. And if I get a linear relationship, oh, I don't have the top graph up there. I would have the middle graph. If I get a linear relationship between the natural log of A and time, then I have a first order reaction. So just like doing a quick select in Excel and plot, I can be like, okay, look, I'm pretty sure my overall order is first order. And that can really help you analyze the rest of your data with confidence. And it's kind of a secondary way of looking at order. Now, if let's say it doesn't turn out linear, instead, so you keep going and you plot the inverse of the concentration of A versus time. That would give us this plot down here at the bottom. If you see a linear relationship, then you have a second order reaction. And that tells you that you have a second order dependence with respect to your concentration. And so that's right here. There we go. I can highlight here too. And if both of those give you a non-linear relationship, then you're like, it's zero order then. And so what you can plot then at that point, if both of them give horizontal lines, then it's zero order. You can also confirm that by plotting the concentration just on its own versus time. And if you get a linear relationship, then you have a zero order reaction. So let's look at an example of this. So here's a reaction that's being studied with SO2Cl2 decomposing into sulfur dioxide and chlorine gas. And so the information that you would probably get in the lab is this piece right here, time and concentration. So this is what you would plot to find out if it was zero order. So I would plot this information here to test if it's zero order. But just when I have this in Excel, I can just click my concentration and hit equals, natural log of that concentration, and I can calculate that quickly in Excel, and then plot time versus the natural log of my reactant to see if I have a first order plot. So then in that case, I'd be looking at the time versus the natural log. And that would be this plot right here. And it would tell me if I had a first order dependence or not. And looking at this, I see that I have a linear relationship. Yay. So that means it's going to be first order. If I didn't get a linear relationship, I might also keep, or if I just did this all at once, I can also take time and plot that versus the inverse, and that would tell me if I had a second order plot. or second order relationship. And since I'm looking at this graph, when I take time versus the inverse of the concentration of my reactant, I don't see a linear relationship. Therefore, it's not going to be a second order dependence on SO2 Cl2. And so just taking this data, I already probably have in Excel from whatever instrument I was using. I can quickly just double check the overall order of the reaction. Um, and so it's kind of it's a really handy tool when we're in the lab and when we're processing our data and trying to like find ways to build confidence in the conclusions that we're drawing.